Hello everyone. In the last lecture, we have discussed about what is meant by artificial intelligence, machine learning, deep learning, what are the different machine learning tasks, what is their categorization, and the different real-world applications of machine learning. So in this lecture, we are going to discuss about the concepts you are going to learn in this course, how to define a well-defined machine learning problem, and how to design a machine learning system. Myself is Dr. GNVT Sirisha, working as Assistant Professor in the Department of Computer Science and Engineering in SRKR Engineering College. The objectives of this lecture are to define well-posed machine learning problem and to design machine learning system. In this course, we are going to learn about designing a machine learning system, what are the different types of machine learning, and what are the issues we have to handle while designing a machine learning system. What are the ingredients of machine learning, tasks, models, and features. Tasks are the problems that we are going to solve in machine learning. Models are the output of machine learning. Models can be categorized into two ways. The first categorization is geometric models, probabilistic models, and logical models. The second categorization is grouping models and grading models. We also learn about what are features, how to construct features, and how to transform features, and how to effectively make use of features in constructing a good machine learning system. Then we discuss curse of dimensionality in situations where the dataset has too many features. When does the models overfit? What is meant by overfitting? Which type of models have the tendency to overfit? And what is the role of data in machine learning? We also learn about how to split the data into training set, which is used to build the model, validation set, which is used for hyperparameter tuning, and test set, which is used to evaluate the model. Then we learn about confusion matrix, how to construct the confusion matrix, and how we can use confusion matrix to evaluate the model. How to use the values of confusion matrix in calculating various evaluation metrics like accuracy, sensitivity, specificity, precision, recall, and F1 measure. Then what is ROC curve and how it can be used for comparing different classifiers. We also learn about what is meant by unbalanced datasets and how to evaluate the models which are constructed on unbalanced datasets. We also discuss about the basics of probability and naive Bayesian classifier. We learn about the basics of statistics like variance, covariance, bias variance trade-off. In the Unit 2, we are going to discuss about what are tree models and especially decision trees. And we learn about linear models, which include linear regression, logistic regression, and support vector machines. We also learn about distance-based models, which include distance-based classification, distance-based clustering. And finally, we learn about hierarchical clustering. In the Unit 3, we are going to learn about features, which are the workhorses of machine learning. What are the uses of features, how to construct features, how to transform the features to make them appropriate for machine learning. We also learn about what is meant by correlated features so that we can remove redundant data from the dataset. Then we learn about how to combine models into ensemble models using different methods like bagging, boosting, random forest, gradient boosting, and XGBoost. In Unit 4, we are going to discuss about dimensionality reduction in applications or domains which contain large number of features. Feature reduction or dimensionality reduction is very important in order to improve the efficiency and effectiveness of machine learning algorithms. So we discuss in detail about two important dimensionality reduction techniques called principal component analysis and linear discriminant analysis. Principal component analysis is an unsupervised dimensionality reduction technique, whereas linear discriminant analysis is a supervised dimensionality reduction technique. Then we learn about model evaluation and optimization using cross-validation techniques, grid search, and regularization methods. In the last unit, we are going to discuss about artificial neural networks. What is meant by artificial neural networks which are designed inspired by biological neurons? In that, we learn about the pioneering artificial neural network that is developed, that is called perceptron, multilayer perceptron, and backpropagation algorithm. We also learn about a recent advancement in machine learning called reinforcement learning. What is the relationship between Markov decision process and reinforcement learning? And what are the different applications of reinforcement learning? So these are the concepts which we are going to discuss in this course. So today we'll see how to write a well-posed machine learning problem. A computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience C. That is, the computer program's performance has to improve in performing a particular task with experience. To have a well-defined learning problem, we need to identify the class of tasks we want to solve, the measure of performance that has to be improved or which is used to evaluate the model, and the source of experience. So we will be discussing these topics with the help of some examples. First, let us take the checkers learning problem. Here the task is to play checkers game. The performance measure chosen is the percent of games won against opponents. Machine learning system gains its experience by playing games with itself. The second machine learning problem is the handwritten recognition problem. Here the task is to recognize and classify the handwritten words within images. And the performance measure used is the percent of words correctly classified. The training experience is the database of handwritten words along with their class labels. The another example is robot driving learning problem. Here the task is the robot has to drive on public highways using vision sensors. The performance measure is the average distance traveled before doing an error. And the robot can gain its experience by using a sequence of images and steering commands recorded by the robot while observing the human driver. Then how to design a machine learning system? The steps involved in designing a machine learning system are choosing the training experience, choosing the target function, choosing a representation for target function, choosing a function approximation algorithm, and the final design. Let us discuss these steps with the help of an example. If you take the checkers learning algorithm, which we have seen earlier. Here the task is to play checkers game. So the machine learning system has to learn to play checkers game. We have already discussed that the performance measure used to assess machine learning system is the percentage of games won against opponents. And the machine learning system gains its experience by playing games against itself. So now we'll see how we can design a checkers learning algorithm by using the steps we have seen here. So I'm repeating the steps again. First one is choosing the training experience. So the machine learning system that is designed to learn playing checkers game can get its training experience either by playing with itself or playing with experts or learning its moves from a table of moves. So the second step is choosing the target function. To determine what type of knowledge will be learned and how this will be used by the performance program. In playing checkers game, it needs to learn to choose the best move among those legal moves. So it has to learn a function which maps B to M, where B is legal board states, M is legal moves. From a particular board state, the machine learning system has to decide what is the best legal move it has to take in the next step. The third step is choosing a representation for target function. The learned function could be represented in the form of rules or mathematical function or in the form of artificial neural network. The next step is determining learning algorithm. The target function can be learned by using a variety of methods like gradient descent, linear programming, etc. And finally, once a machine learning system is properly learned, we get the completed design. So these are the different steps involved in designing a machine learning system. Thank you.